Fire testing and certification play a crucial role in ensuring the safety and effectiveness of materials and products in the event of a fire. Standardized testing methods are employed to evaluate the fire resistance of various materials, such as building materials, furniture, and electronics. This module will explore the different testing methods used to assess fire resistance and will provide a detailed overview of each method. The cone calorimeter test is a widely used method for measuring the heat release rate, HRR, and other fire-related parameters of materials. It involves placing a sample of the material in a controlled environment and subjecting it to a radiant heat source. The heat released by the sample is measured, and various parameters such as ignition time, peak heat release rate, total heat release, and smoke production are determined. This test provides valuable information about a material's flammability and its potential to contribute to fire growth. The single burning item test is designed to evaluate the fire performance of building products. In this method, a single specimen is exposed to a heat flux, similar to that produced by a burning object. The specimen is placed vertically and ignited from the bottom using a controlled flame. The spread of flames, heat release, smoke production, and burning behavior are measured and assessed. The SBI test provides valuable information about a product's reaction to fire and its contribution to fire growth. The room corner test is intended to evaluate the fire performance of wall and ceiling finishes. This test simulates a room corner by exposing a mock-up of the finish to the radiant heat from a gas burner. The test evaluates the rate of heat release, smoke production, and flame spread from the corner mock-up. This method reflects real-life scenarios and helps determine a finish's ability to contain or contribute to fire spread within a room. Oxygen consumption calorimetry is a method used to measure the heat release rate of materials or products under controlled conditions. The test involves placing the specimen inside a combustion chamber and monitoring the oxygen concentration, temperature, and heat release rate. This method provides valuable information about a material's combustibility and its potential contribution to fire development. The smoke density test is used to measure the specific optical density of smoke generated by burning materials. This method involves exposing the material to heat and capturing the smoke produced. The smoke is then passed through a measuring chamber, where its optical density is determined. This test helps evaluate the smoke generation and its potential to hinder evacuation and rescue operations during a fire. The fire resistance test for structural elements is concerned with assessing the fire resistance of building components, such as walls, floors, and columns. These tests involve subjecting the structure to a standardized fire curve, which simulates the time-temperature relationship of a typical fire. The resistance of the structural element to fire is determined based on its ability to maintain load-bearing capacity, integrity, and insulation for a specified duration. The electrical cable fire performance test is used to assess the flame propagation, smoke production, and acid gas emission of cables subjected to fire. This test involves subjecting the cable to a controlled flame and measuring various parameters such as flame spread, heat release, smoke density, and release of corrosive gases. It helps determine the performance of cables during fire incidents and their impact on the spread of fire and survivability. Standardized testing methods for fire resistance play a crucial role in ensuring the safety and reliability of materials and products. The cone calorimeter test, single burning item test, room corner test, oxygen consumption, calorimetry, smoke density test, fire resistance test for structural elements, and electrical cable fire performance test are some of the widely used methods in fire testing and certification. Understanding these testing methods is essential for manufacturers, architects, engineers, and regulators to ensure proper fire safety measures and compliance with regulations.